simple harmonic motion. Now, if x is at the centre, then that means that you go a above and a below. So that's plus a and minus a. So the endpoints are basically c plus a or c minus a. If the centre was 0, then that would be x is 0, and x is a, and x is minus a. Okay, so when you're looking at that now, at the endpoints velocity is 0. In the middle, velocity will be a maximum. Because if you think about that at the centre, when you have something in simple harmonic motion, it has its greatest speed at these points of inflection when the acceleration is equal to 0. That's when it reaches its greatest speed or its greatest slope. So the velocity is like the slope. V is 0 at the endpoints, and V is a maximum when the second derivative is 0. So that means in the middle, the acceleration is 0, because that's at these points here, at the points of inflection. And at the end points, the acceleration is a max. So the actual formulas, like if we look at the formula, we'll do it for the centre. If the centre is at the origin, so the centre is at x, then basically for it to be in simple harmonic motion, you have the displacement. So the displacement is any form of sine or cos curve. So that's sine nt plus alpha, a sine nt plus alpha, a cos nt plus alpha, or a combination of the two. And just note, when you do have a combination of the two, like this is the amplitude is a in these, that's the amplitude, and the period is 2 pi over n. The alpha, it just shifts it to the left or the right, but it doesn't affect its period or its amplitude, it's just a horizontal shift. The thing is that when you've got, in this situation here, using the auxiliary angle method, you can put it into the form of sine nt plus alpha, and it'll be, might use a different angle there, let's just see plus theta, and that'll actually be where the r is equal to the square root of the a squared plus b squared, because it comes from this triangle here, and that a that is here becomes the a that is the adjacent side, and the b that is there, the b will be the opposite side. So if you look at this, this will be theta, and this will be b over a, it's the adjacent side, and that's r. So by Pythagoras, r is a squared plus b squared, and tan theta equals b over a. So to actually get that angle, or that shift, it'll be tan the minus 1 of b on a. So you can actually put this back into just a simple sine function, or you could do it as a cos function, and you just use the auxiliary angle, and the r just becomes your amplitude. Okay, so that's the displacement for this. The velocity is v squared equals n squared a squared minus x. And the acceleration.
What one was that?
So the velocity is just v squared is n squared, a squared minus x squared. The acceleration is equals minus n squared x. Now if you have the same thing and you shift your centre, so you have your centre is at x equals c, then all of those displacement graphs that we just looked at, so a sine nt plus alpha, all you're doing is adding c on. So it just means that it goes up c. If x equals a cos nt plus alpha plus c, that would go up c. And the same, even if you had this graph here, you just have to add c on the end and it would shift up c. So what it's actually doing is it moves it to c, and then it oscillates either as a sine curve or a cos curve, and it goes C plus A and C minus A. So it'll do exactly the same thing. Even if you had, the one with the sine and the cos, so you go A sine nt plus alpha plus B cos nt plus alpha plus C. It means it'll just go up C. And see, that can then be put in the form of sine nt plus theta and then plus C, okay, as the auxiliary angle. And R is the amplitude, which is just equal to the square root of A squared plus B squared. So nothing much happens to the period and the amplitude. The whole graph is just shifted up. So with that, you can then shift also your velocity graph. So your velocity becomes v squared n squared a squared minus x minus c squared. So it's just shifted. And your acceleration becomes minus n squared x minus c. So if you see a velocity graph and it looks like something like this, that's actually something that is a quadratic, and it will be in that form, as opposed to the one that just looks like, say, 9 minus x squared. That one's in this form with the center 0, 0. So if it has like a middle term, it's actually this one, and it can be written as a quadratic, and that's how you can tell whether its center is at 0, 0 or its center at C.